Have you ever stopped to think about the sheer speed, the complexity behind some online interactions?
You mean like online bidding?
Exactly. How does a system instantly figure out a dynamic price or, spot fraud, basically in the blink of an eye?
It's a massive technical challenge, absolutely.
Well, today, that's exactly what we're digging into. We're doing a deep dive on the technical design of a real-time online product bidding system.
And this one's specifically engineered on the Databricks Lakehouse platform.
Right. And our source material for this, it's this really comprehensive technical design document.
Yeah, it's got everything, even code snippets.
It gives us the full blueprint, pretty much from the front-end simulation all the way to the back-end analytics.
And our mission here for this deep dive is really to pull out those crucial insights. How is a system like this, a high-stakes system, engineered?
Not just to work, but for that extreme speed, right?
Exactly. Speed, intelligence, and that unwavering reliability. We'll unpack the core pieces, trace how the data flow.
Helping you understand the how and the why.
Right, how these sophisticated systems actually operate under all that pressure.
Okay, so let's start with the basics. What's the fundamental goal of a system like this?
Well, at its core, it's about enabling these incredibly low-latency bidding and pricing workflows.
It's the AI-driven part.
Yes, AI-driven, and able to handle just massive volumes of user interactions seamlessly.
So when we talk about real-time intelligence at scale, what capabilities does that actually translate to? What does the system need to do?
Okay, functionally, there are several critical requirements. First, real-time ingestion. It has to grab all the user bids, all the product activity instantly as it happens. Then it needs to rapidly process that data, enrich the streams for, detailed bidding analysis.
That makes sense.
A huge piece is the AI for dynamic pricing, for user recommendations.
Personalized stuff.
Exactly. And just as vital are robust pipelines for validating those bids and detecting potential fraud.
Can't forget security.
Never. And finally, it has to give end users immediate access to their bidding history, the outcomes, all personalized.
Okay, but what really makes this worth a deep dive, I think, are those non-functional requirements. The demands seem incredible.
Oh, they are, especially the performance demand.
Like that latency target.
Yeah.
How hard is it to actually hit that, say, sub 10 millisecond mark consistently?
It's extremely challenging. That less than 10 millisecond latency for placing a bid or getting a price decision, that's lightning fast.
Wow.
And beyond speed, you need high availability, massive scalability, rock-solid security.
Fault tolerance, too, I imagine.
Absolutely critical, especially in those ingestion and model inference pipelines. You can't lose data. You can't lose a decision.
Right.
And underpinning everything is comprehensive data governance, lineage tracking, auditing capabilities. Those are non-negotiable.
So it sounds like these ambitious goals really dictate every single design choice.
That's what's fascinating, yeah. From the platform itself right down to the specific algorithms. It's not just about does it work. It's about speed and reliability at enormous scale.
Okay, so given those intense demands, how did they actually architect this thing? Let's unpack the high-level architecture. You mentioned the Databricks Lakehouse platform is core.
It is. It forms the foundation.
So what are the main pieces, the components that make it all tick?
All right, at a high level, think of it as several specialized components all working together on that unified Databricks platform.
Okay.
You've got the bidding front end, that's what the user sees, probably React or Flutter, web, or mobile app.
Standard stuff.
Then data hits the ingestion layer. This captures all the real-time events. Critically, it uses tools like Databricks Autoloader.
Ah, for efficient streaming ingestion, right?
Exactly. It handles incremental data really well. And Delta Live tables are key here too.
Why DLT?
Well, they automate pipeline management and importantly, let you embed data quality checks right into the pipeline. Early detection of issues.
Nice. Okay, what's next?
Stream processing. This handles the real-time joins, filtering using structured streaming and Delta Lake.
Delta Lake providing that reliable storage.
Right. ACD-compliant storage for both batch and streaming data. Then for the AI side, there's feature engineering.
Using the feature store.
Correct. The Databricks feature store manages those version ML features, ensuring consistency between model training and when the model actually makes a prediction.
Super important for accuracy.
Crucial. Then you have model training and scoring. This uses MLflow, maybe AutoML, the model registry. All for building and managing the models.
Like price prediction, fraud detection.
Exactly. Price prediction, fraud, bid success scoring, all that. Then for actually using the models in real time, there's model inference.
How does that work?
It provides those near real-time predictions, usually through Databricks model serving or maybe a custom REST endpoint.
Got it. And the data for analysis.
That lands in the data warehousing layer. Again, Delta Lake is the storage, access via Databricks SQL governed by Unity Catalog.
Unity Catalog seems to pop up a lot.
It's central for governance and security. It handles access control, lineage, compliance across the whole system, along with audit logs and standard role-based access control.
So if I'm picturing this right, it's kind of like a highly specialized factory floor. Each station has a very specific, optimized job to do.
Yeah, that's a good analogy.
To get that product, that decision, out the door incredibly fast.
Precisely. Each component is optimized for its task within the overall flow.
Okay, here's where it gets really interesting for me. How does a single bid or maybe a product update actually flow through this whole complex setup from click to decision?
Right, let's trace that data journey. It really kicks off at the ingestion layer.
Where the data first arrives.
Exactly. You've got various sources feeding in, bid events, often JSON messages via something like Kafka.
High throughput.
Yep, product updates, maybe also JSON via a REST API, user activity logs, maybe from PubSub or similar services.
It's diverse sources.
Very diverse. But Databricks Autoloader handles ingesting all of them into these raw Delta Live tables. For instance, you might have a table called bids raw.
Okay, so it's landed in the raw zone. Then what?
Then it moves through a series of intelligent processing pipelines managed by Delta Live tables.
What happens there?
First, bid validation. This is crucial, deduplicating bids, enforcing the schema, basic filtering like making sure the bid amount is positive.
Cleaning things up.
Right, cleaning user IDs, product IDs, ensuring data integrity from the start. Next comes future enrichment.
Adding more context.
Exactly. Joining the bid data with product metadata, user metadata, creating richer data sets that are much more useful for analysis and ML.
Makes sense.
And finally, you have processes like fraud scoring and dynamic pricing that run. These actually call out to the ML models to get predictions.
Ah, so the inference happens as part of the pipeline flow.
Often, yes, integrated directly into the stream processing or triggered very shortly after.
And you mentioned the source doc even has a simulator example.
Yeah, a simple Flask-based front-end simulator. It's neat because it shows exactly how bid events could be generated, just simple JSON files written to a specific location.
So it demonstrates that entry point.
Precisely. It shows how the real-time system picks up those files instantly and starts the whole process we just described. It makes that ingestion step really concrete.
That ability for the system to think, to make those AI decisions in real time is just, well, it's astonishing. What are the specific ML models doing the thinking here?
Yeah, the AI is the brain, right? The system relies on several core ML models.
Like the ones you mentioned?
Yes. There's typically a price predictor, often using something powerful like XGBoost, or maybe AutoML helps find the best model to suggest dynamic prices.
Adapting to the market.
Constantly. Then there's a fraud detector. The example uses isolation forest, which is interesting.
Why isolation forest?
It's really good at quickly spotting anomalies or outliers in big data sets without needing predefined labels, which makes it great for real-time fraud detection where speed is key. And finally, maybe a bid success model, often something like logistic regression.
Why logistic regression?
It's efficient and gives you a clear probability what's the chance this specific bid will actually win. Plus, it's quite interpretable.
And you said the feature store is critical for these.
Absolutely crucial. The feature store integration ensures consistency. It stores all the versioned ML features
That the models need.
Right. Both for training the models initially and for making predictions later, inference. It guarantees they're using the exact same feature calculations.
No mismatch between training and serving.
Exactly. And you'd have different feature groups stored there, maybe a user profile group with stuff like average spend, bid frequency, win ratio, a product metrics group, historical price, number of views, maybe some demand curve estimates, and bid context features time of day, session length, device type, all versioned and managed.
That sounds like a really robust ML lifecycle. But in a system deciding things in milliseconds, how do you keep those models accurate? How do you deal with drift?
That's a constant challenge, you're right. Market conditions, user behavior, they change fast.
So how is it managed?
Well, the models are trained using tools like MLflow and maybe AutoML. Everything is meticulously logged and versioned in the MLflow model registry. That gives you reproducibility and traceability.
Okay, training and tracking.
Then they're deployed, often via Databricks model serving for that low latency inference. But it definitely doesn't stop there.
Monitoring becomes key.
Continuous monitoring, you have to watch for data drift, track prediction latency, monitor the model's accuracy over time.
Because the real world changes.
Exactly. So that real-time inference is vital. Models deployed via model serving are typically accessible via a simple REST API endpoint.
Making it easy for the pipeline to get predictions.
Right. It allows the system to react incredibly quickly to new bids, new information, using the latest model insights.
Okay, so we have the data flow, the AI making decisions.
Yeah.
But keeping this whole high-stakes operation running 24/7 must be intense. What's the underlying infrastructure, the security, the monitoring that keeps it all stable?
It relies heavily on the Databricks platform resources to provide that backbone.
Like what specifically?
Well, a Databricks workspace itself is the central hub for collaboration. You use jobs to orchestrate all the pipelines, scheduled or triggered.
And compute?
Provided by clusters, which can auto-scale and are optimized for both the heavy ETL lifting and the ML workloads.
Makes sense.
Delta Lake is the unified storage layer, managing data across those bronze, silver, gold stages reliably.
We talked about that. And Unity Catalog again.
Absolutely critical. Unity Catalog is the central nervous system for data governance and access control, fine-grained permissions, lineage, discovery, all in one place.
Are there integrations with external systems too?
Oh, yes, definitely. You'll have things like Kafka or PubSub feeding in the streams, maybe Redis or Memcached as an optional caching layer.
For even lower latency reads.
Exactly, for things like feature lookups during inference, and then external APIs for, say, inventory systems, payment gateways, maybe third-party authentication.
Right, it doesn't live in a vacuum. Now, security and governance, how is access controlled? How do you protect sensitive bidding data?
It's multi-layered. Role-based access control, RBAC, is fundamental, and that's managed directly through Unity Catalog.
So you control who sees what data, who can run what job.
Precisely, at a very granular level. Plus, you have strong authentication for APIs, using tokens or service principals.
What about sensitive data itself?
Data masking techniques can be applied, classifying and protecting PII. And absolutely critical is comprehensive audit logging.
Tracking everything.
Every data access, every change, every model action is logged, providing that immutable record for compliance, security reviews, and troubleshooting.
And you mentioned monitoring earlier as part of the ML lifecycle.
Yes, and it extends to the whole system. If you connect this to the bigger picture, robust monitoring is what keeps the system trustworthy and accurate.
How so?
It allows the system to adapt. You monitor for job failures through the Databricks UI and alerts, catching pipeline problems quickly. You monitor data quality continuously using those Delta Live tables expectations we talked about.
Catching bad data early.
Right. You monitor for model drift using MLflow metrics and custom alerts vital for AI systems. And you monitor access via the Unity Catalog audit logs for security.
Wow, that's a lot to track.
It has to be, for a system operating at the scale and speed.
Okay, so this system is churning through data, making predictions, running pipelines. It must generate a massive amount of information. How do people actually make sense of it all? How do they get actionable insights?
That's where Databricks SQL and the dashboarding capabilities really shine.
So analysts can just query the data.
Exactly. They can write standard SQL queries directly against those clean, gold-tier Delta tables without needing to wrestle with the raw complexity.
What kind of things would they query?
Oh, all sorts. Total bids per hour, the top 10 most active bidders, average bid amounts, maybe bid success probability broken down by user segment, fraud alert counts.
Real operational and business metrics.
Absolutely. Deep, immediate insights into how the system is performing, how the market is behaving.
And then they visualize this.
Right. These queries feed into Databricks SQL Dashboards. These can be set to auto-refresh, so you're always looking at near real-time data.
And easily shared.
Yep, shared with business leaders, operations teams, whoever needs that up-to-the-minute pulse on the bidding ecosystem.
That really closes the loop, doesn't it? All that complex processing pays off by delivering clear, actionable insights for making fast decisions.
That's the goal, turning that real-time data flow and AI analysis into tangible value.
So looking ahead now, a system like this is already incredibly sophisticated. What's next? How could it evolve or become even smarter?
Well, the technical design doc actually lays out some planned future enhancements, which is interesting. It shows it's not static.
Like what?
Things like supporting more complex bidding scenarios, group bidding, or maybe bundle pricing strategies, going beyond just single items.
More complex market dynamics.
Exactly. Also, adaptive retraining of models.
Right.
So Automatically retraining based on market seasonality, for instance. Letting the AI adjust without needing manual intervention.
Smarter automation.
Right. And deploying multi-model routing using feature flags.
Well, what did that allow?
It lets you do things like A/B test new models easily or gradually roll out a new model version to just a fraction of users first. More deployment flexibility.
Cool. Anything else?
One more thing mentioned was integrating with a vector search engine.
For recommendations?
Yeah, for more contextual product matches. Understanding the semantic meaning behind searches or user behavior to find similar products, leading to potentially much better recommendations.
Fascinating stuff.
Sure.
It really shows how these systems are constantly evolving. So, as you can clearly see, building something like this real-time AI-driven bidding system, it's an incredible piece of engineering.
It really is.
It relies completely on that seamless data flow, those really sophisticated ML models we talked about, and just a robust, scalable infrastructure.
One that handles immense pressure and delivers those decisions in milliseconds.
Yeah.
And, you know, it's worth considering how these advanced real-time AI systems are shaping so much more than just online bidding.
They're everywhere, often behind the scenes.
Exactly. Working silently in countless parts of our digital life. It makes you wonder, what might be the next industry that gets fundamentally transformed by this kind of immediate data-driven intelligence?